Okay, so now let's discuss the formula of velocity. Formula of velocity. So in my previous video, we discussed the formula that when the time is same, when t1 is equal to t2, that was equal to t, means it the time was time same, right? But now today let's look at the formula when distance is same, right? When the distance is same, right? So we have the formula v is equal to d1 plus d2 t1 plus t2, right? This is a formula of velocity. Now we know that d1, let me write this from another color. We know that d1 is equal to d2 and they are equal to only d, right? So let's replace this. V is equal to d plus d upon t1 plus t2, right? So we know, let's find the formula of velocity. Okay, we know that velocity is equal to s upon t, right? And we have to find the value of t. So t will be equal to s upon, which is basically distance, which is distance upon velocity, right? Here, let me replace this over here too. Here distance will come, right? This is a formula of time. So can we replace this? Yes, we can replace this. Now when we know that d1 and d2 both are equal, so we will only place d. The v is equal to, now d plus d are equal to 2d, and now t means d upon v1 plus d upon v2. Now this is the equation, right? Okay, we know that we can cancel them out. D, D, D. These are cancelling, right? Now what is left? V is equal to 2 upon 1 upon V1 plus 1 upon V2. When we take LCM of it in the bracket, only look at 1 upon V1 plus 1 upon V2. Now what is the LCM? It will be V1, V2, v1 plus v2. This will come, right? Let's put this here. Now what will happen? V is equal to 2. Here v1 plus v2 is equal to v1 v2, right? Now this will go up and it will become v is equal to 2 v1 v2 upon v1 plus v2, right? So this is basically the formula of velocity when distance is same. When distance is same, right? I hope this is clear to you. Okay, now let's look at one problem too, so you can easily understand this formula, right? So for example, this is a path. Okay, consider that this is a point. This is a point. This is a point. Point is point A, right? I have moved to point C now, and in the mid there is point B, right? And the distance is like here, from here to here, the distance is 50 kilometer, right? And from here to here, the distance is 50 50 50 kilometer, right? So the speed from A to B is, your speed from A to B is, like velocity is equal to 40 kilometer per hour, right? And here, okay, basically it's 40 kilometer, not kilometer per second. And from here to here my velocity is equal to 50, right? 50 kilometer per second, right? Okay, now let's find out, and they are saying that we have to find the average velocity. In the question it's saying that we have to find the average velocity. How will we be able to find which formula you will apply? So as you can see over here, the distance is same, 50 kilometer and 50 kilometer, right? The distance d1 is equal to 50 kilometer and d2 is also equal to 50 kilometer, right? So it means we will apply over here, we will apply this one formula, right? Okay, oops. Let's apply. What is the formula now? We know the average velocity, if the distance is same, 2v1 v2 upon v1 plus v2. This is the formula of average velocity, right? Now let's put the values. Now to same, v1 is equal to 40 kilometer, right? We will write here 40 bracket, and v2 is equal to 50, right? This is basically 50. Let's write here 50. Okay, now and here v1 plus v2. Now v1 is 40 and plus 50, right? So now let's do the calculation. We will find the, after we'll do mathematician, we will find 2000 upon 90, and we know that 0 will cancel from 0. What will be left? 200 upon 9, right? Usually 200 upon 9 will be left. So this is our average velocity of these both diagrams. So let's find out that what is the sum of this 200 divided by 9. Let's find out this. So 200 divided by 9 is basically 22.22 meter per second. So basically this is our answer. So I hope this is clear to you.